So last week we started with the pinhole cameras, and I told you today we are going to look at the mathematical representation of the pinhole cameras. So mathematical expression of pinhole cameras, that's what we are going to look at today. We are going to talk about mathematical expressions on the pinhole camera. Now, the other day, when we were considering the pinhole cameras, we consider the object distance, we consider the image distance, we consider the object height, we also consider the image height. I hope you remember when I did the distance. And we said that the object distance is the distance from the object to the pinhole. I mean, I said the height of the object is the object height. And we also said that the image distance is the distance from the pinhole to what they call the screen where the image is formed. And the image distance is the image height is the height of the image. We looked at that the other time. Now, looking at all these factors, we are going to consider something called linear magnification. That's noise at the background. Linear magnification. Now, when we talk of magnification, we are saying that it gives an idea of how many times an image is bigger than the object. So the linear magnification gives account on how many times an image is bigger than the object. Now you bear with me that when you have a camera, or when you are taking someone picture, you bear with me that normally when you are snapping someone, you realize that normally the distance with which the distance from the camera and where the person is normally plays a lot of role, and that is the image, the object distance. So the closer you get to the person, the more appealing picture you get. That is it. Now when you go further away from the object or from the person, you realize that you get a picture, but it won't be as clear as when you get closer to the person, and that in turn also affects the image you form. You also bear with me that the height also matters. So when you're snapping someone picture and perhaps maybe the person is a little bit or more taller than you, then that means you have to go back before you can be able to get a full picture of the person. But when a person is very small or short, you can just go close to the person and can get a full view of the person. So that is it. So the magnification normally gives an account on how many times an image is bigger than the object. And so we are going to consider magnification. Now magnification is dependent on, number one, the image distance, is dependent on the object distance, it is dependent on the image height and the object height. So we therefore mathematically can define magnification as magnification is equal to image height all over object height, and that's also denoted by h naught, small h naught. That is it. So the magnification is given by, so we can now say that magnification is given by h subscript I all over h naught. H naught. So magnification of a picture or magnification of an image or magnification in terms of pinhole camera is dependent on the height of the object, and that also affects the height of the image you are going to get. That is it. Now it also depends on, or it's also affected by the distance. So if you are snapping a picture, it is affected by the distance. So if the person is closer to you, the more closer, the more sharper you can get a correct image. When a person is further away from you, you realize that the quality of the picture gets diminished or gets small, or you don't really get the distance. So it's also dependent on the distances. So it can also be equal to the image distance, which is u, all over the object distance, which is image distance, which is v, all over the object distance, which is u. So that is it. So magnification and the pinhole cameras is dependent on the height of the image and the height of the object. It's also dependent on the distance from the camera or the pinhole to the image, and that of distance from the pinhole to the object. So that is it. So looking at this formula, we can now see that m is equal to hi all over h naught, and m is also equal to v all over u. So then we can say that, okay, then hi all over v, hi all over h naught is equal to v all over u. We can equate them. We can equate the two of them and solve them. So anytime you are given work, that is it. Now, if the magnification is greater than 1, then that means the image is bigger than the object. So anytime you get a magnification greater than 1, then that means the image is bigger than the object. However, if magnification is lesser than 1, then that means the image is smaller than the object. Now, if magnification is equal to 1, then that means the image is equal to, the size of the image is equal to the size of the object. That is it. So if the image is lesser, magnification, sorry, is lesser than 1, and that means the image is smaller than the object. However, if the magnification is greater than 1, then that means the object is, what do you call it? The image is bigger than the object. If it is equal to 1, then that means the image is equal to the height, or the size of the image is equal to that of the object. That's it. Now let's do some calculations on this. So let's do that. A tall man, there's not at the background, so I'm straining. A tall man of height 1.8 meters. A tall man of height. A tall man of height 1.8. A tall man of height 1.8 meters. A tall man of height 1.8 meters stands in front of a pinhole camera. A tall man. A tall man of height. A tall man of height 1.8. 1.8 stands in front of a pinhole camera. Of a pinhole camera. His image is formed on the screen. So let's do the solution. I hope you can see the question. A tall man of height 1.8 meters stands in front of the pinhole camera. And so the height of the man is 1.8. So height of man, which is the man now becomes the object. So height of object is 1.8 meters. 1.8 meters. Now stands in front of a pinhole camera. His image is formed on the screen, which is 12.5 cm away from the pinhole. So this one will become the image distance. The image distance we are given to be 12.5 cm away from the. If the height of the image is 20 cm, so the height of image is height of image hi is what 20 cm. How far is the man from the camera? How far is the man from the camera? So we are talking about the object distance, which is u. We don't know of the object distance, so that's it. So according to our formulas, we can say that hi all over h naught should be equal to v all over u. So, but we are looking for u, so we can make what the subject, u the subject. Now when we make u the subject, what are you getting? You are getting u to be equal to v h naught all over hi. Now when we get this, u will be equal to, we know vein, we are giving vein to be 20 cm. But don't forget that the two of this are in centimeters and this is in meters. So it's either we change this into meters or we change this one to centimeters. We can, changing this to meters will be very expedient. So this will be 12, we have, this will be 12.5 times 10 raised to the power -2 times 10 raised to the power -2 times h naught 0.8 divided by hi is 20 times 10 to the power what do you call it, -2. Use your calculator to tell me, what are you getting? What are you getting? What do you get? For my me, what do you get?
I got 1 point.
It's okay, I've written it there.
1.1.
It's okay, I've written it. I've written it, don't worry. Do this one for me. An object of height 250 cm. An object of height 260 cm. 250. An object of height 250 cm. An object of height 250 cm is placed at a distance of 90 cm in front of a pinhole camera. An object of height an object of height is placed is placed at a yeah. Do this one for me. Do this one for me. There's it. So do it. Do it for me. I'm waiting. What are we getting? What do you get?
So please for the height of the image, I had 5.625.
No, 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 no. Check it again. Check it again. What do you get for the magnification?
I'm not done with that one.
Okay. Check the distance again. Check the height again. What do you get?
For the image distance.
Yeah, what do you get? The question says find the height of the image or height of the image.
1.11.
1.11 what?
11 meters.
Okay, okay. But they are in centimeters, so you could have solved everything in centimeters. The magnification, what do you get?
The magnification, I had I had 0.4 meters.
Oh, okay. Yeah, correct. Let's do shadows. Shadows. So when we talk of shadows, I know already you know what shadows are. So you can relate very fast. Now when we say shadows, we are saying that a shadow itself is an area. Is a so that a shadow is a shadow is the area of darkness. You know, a shadow is always an area of darkness.
Yeah.
Of
Yes,
darkness. And that is normally cast on a screen. That's normally cast on a screen by an opaque object. By an opaque object. An opaque object. That is normally placed between a source of light. Between a source of light. And the screen. So now let me listen. Before a shadow will be formed, there should be number one, there should be an opaque object. And the reason why an opaque object is a necessity is that you know opaque objects light do not pass through. So they absorb the light and they reflect it. So they do not, what do you call it? They absorb the light, sorry, they don't reflect, they absorb the light. So opaque object light cannot pass through an opaque object. And so what happens is that when an opaque object comes in between a light source and a screen, then it forms what do you call it? Darkness on the screen. And that darkness is a representation of what do you call it? The opaque object. And so let me say it's the image of it on a screen. On a screen. So before an opaque, a shadow can be formed, there should be that area, what do you call it? There should be the light source. There should be, what do you call it, a screen, and there should be the opaque object itself. I hope I've made myself clear. So when an opaque object is placed in a part of the light is blocked, and therefore a dark image is cast. And so the light is, the path is blocked, and a dark image is cast. Now that dark image is what we call the opaque, the shadow. The shape of the shadow is similar to the shape of the opaque object. It's a representation of what we call the opaque object. The shape of the shadow is formed by the principle of rectilinear propagation of light. So it is formed by the principle of rectilinear propagation of light. That is it. Formed by the principle of rectilinear propagation of light. Now we are going to consider the two main types of shadow formation. We have two main types of shadow formations. We have the umbra and we have the penumbra. Now when we talk of the umbra, we are talking about total darkness. Total darkness is where that is the umbra. When we talk of the penumbra or penumbra, then we are talking about the partial darkness. So we have the umbra and we have the partial or penumbra. That is it. So the two types, the types of the types of shadow formation, types of shadows. We have the umbra or umbra, which is total darkness. I'll explain all of them. Total darkness, and we have the penumbra. This one is partial darkness. Now, I'll explain how each of them is formed. Already, we have ascertained the fact that before shadow can be formed, there should be the presence of an opaque object that will block the light. As a result, cast a dark image on a screen. So there should be the light source, number one, and there should be an opaque object, and there should be a screen. Now, based on their formations, we can group them into two types. We have the total darkness or the umbra, and we have the penumbra, which is the partial darkness. Now, let me explain. The umbra is a shadow cast by an opaque object between a point source. Normally, the umbra is normally between a point source of light and a screen. So the umbra is always between a point source of light and a screen. It is the area of total darkness. So the umbra is always between a point source. So the emphasis is on a point source. The emphasis is on a point source of light. The emphasis is on a point source of light and the darkness and the screen. So, for instance, you realize that when you're in a room at night and you just have maybe a bulb, the shadow you form will be very much deeper than when you are maybe outside and there are a lot of street light, like 2 or 3, and you are in it or something. You realize that the shadow you form, that one is a little bit lighter or partially dark. That is what it means. Or even during daytime when you're walking, the shadows you form, some of them you don't even see it, but you have formed it. Some you see it, but they are very faint. And normally when it is at night, because the light is not really bright or not too much, you realize that the shadow will be very deep or very dark. I don't know if you get my point. So the difference between the umbra and the penumbra is that the umbra is formed when an opaque object comes between a point source of light and a screen. Now the penumbra is formed when an object comes in between an extended source of light and a screen. So the penumbra has to do with an extended source of light, like the sun. It's an extended source of light. And we can talk of an umbra is formed from a point, maybe a normal bulb, like maybe at night. You get it? So one is from an extended source of light, one from a point source of light. So that is this thing. I wish I could demonstrate it by a diagram, but it's okay. So this one is from a point source of light. Source of light. Point source of light. This one is from extended source of light. External source of light. That is it. I hope you've seen it. I hope I've made myself clear.
Yes, sir.
And it is this same principle that leads to the formation of the eclipse. You know, the eclipse, there's a shadow formation and so on and so forth. So we are going to also briefly talk about the eclipse formation. Then we are done for the day. We are briefly going to talk about the eclipse formation. Now we have, when we talk of eclipse, then we are saying that eclipse in the first place, we have 5 minutes. I wish I could be able to finish this thing right now so that we close. Eclipse. When we say eclipse is a total or partial. The total or partial disappearance. Total or partial disappearance of the sun or moon as seen from the earth. So it is a total or partial disappearance of the sun or moon from what do you call it? Sun or moon as seen from the earth. So it's a total or partial disappearance of the sun or moon as seen from the earth. And so and normally happens because of the relative position of the sun and the moon. You realize that the earth is a planet and it orbits around the sun. And so due to the rotations and the relative positions of the sun, the moon, and the earth itself, there are some instances that because of their movement, one comes in between one and the rest, and as a result, there's a shadow cast on one of the bodies. Now, we are going to consider the three main types of eclipse. We are going to consider the solar eclipse, which is eclipse of the sun, and in the eclipse of the sun, it normally occurs when the moon comes in between the sun and the earth. And so it normally occurs when the moon comes in between the sun and the earth. Now, when the moon comes in between the sun and the earth, what happens is that you know that the moon, before the moon comes in between the sun and the earth will be benefiting or be enjoying, or what do you call it, the sun. Now, when the moon comes in between the sun and the earth, you know the moon is an opaque object, so it blocks the sun from reaching the earth. As a result, it casts a shadow on the sun, on the earth. Now, when it casts a shadow on the earth, then you are going to get some part of the earth is going to, because the moon is very small, some part as compared to the earth, some part of the earth is going to experience total darkness. While some part of the earth will experience partial darkness. Are we getting it? So with that, we are directly under the moon. At the time the eclipse occurred, we are going to experience total darkness, and some parts of the earth will also experience partial darkness. That is it. Now, from there, we look at another type of the eclipse. We call it the annular eclipse. Now, when we say the annular eclipse, it's also another type of what do you call it? It's also another type of the solar eclipse. But in this case, the moon is positioned further away from the earth. So normal, because the moon is positioned further away from the earth, though there will be, and the moon still comes in between the earth and the, talk to me.
The spelling of the, is it annular?
Annular, ANNULAR. So it's a type of solar eclipse that occurs when the moon is positioned further away from the earth and the umbra does not fall on the earth. Because the moon is positioned further away from the earth really doesn't experience the total darkness as if it was closer to the earth it would have experienced. And so though eclipse will occur, but because the moon is positioned further away from the earth in that sense, we might not experience full total darkness, or we might not even experience that there's darkness because the moon is positioned further away from the earth. So we might not experience the total darkness. Now the last one before I end, the next time we consider the diagrams and the rest, is the lunar eclipse. There's eclipse of the moon, lunar, LUNAR, lunar eclipse. There's eclipse of the moon. And normally that one occurs when the earth comes in between the sun and the moon. It occurs when the Earth comes in between the sun and the moon. And you know definitely the Earth is a bigger body. So as a result, it casts total darkness on the moon. And when it casts total darkness on the moon, definitely there'll be total darkness. Let me put it that way. And this normally occurs at night because normally the moon functions at night. And so, or we experience the moon, presence of the moon at night. So that normally occurs at night. But because at night now it's already dark, sometimes we don't even experience it unless we are being told. Because already at night we have our lights and everything on, and night is always dark. So that is what happens.